I called this the constant acceleration equations. It should be called Science 10 done properly. I'm really not a fan of the way they teach acceleration in Science 10. We're going to start off with just a specific example to let you know that this does all still tie in to all the graphing that we did. Here's a graph. Raven, what kind of a graph? What's on the y-axis there? Just read. Speed. What's on the x-axis? Time. It's a speed versus time graph. Okay. The first thing I ask you folks is, what's the acceleration? How do I find the acceleration from a speed versus time graph? Hey, I'm looking for a word that starts with the letter S and rhymes with Pope. Slope. Let's go rise over run. So I'm going to use this point right here, which I think is 0, 2. And I'm going to use the very, very tippy top point right there, which I think is 0.8, 10. So you ready, Raven? Here we go. How high are we at the bottom here? 2. How high are we at the top here? What's the rise in your head? 8. Right? So I'm going to say A, because it's acceleration, 8 over. From 0 to here, what's the run? I think, Raven, just 0.8, yeah? Folks, what's 8 divided by 0. Oh, it works out even. 10. Yes, I think? Yeah? 10. 10 what? It's acceleration. Meters per second is velocity. It's meters per second, meters per second squared, right? In fact, I can write an equation for this graph. Now, the equation is going to be based on y equals mx plus b. But what should I use instead of the letter y? What's on the y-axis? What would be a smarter letter to use? On the y-axis. V, yes? Don't overcomplicate it. V equals, now here is the slope. We just found the slope in part A, 10. What should I use instead of x on the x-axis? T plus y-intercept. You can just read it from the graph. 2. I want you to notice something. If I generalize this, what's that 10? What did we say the slope of a velocity or speed versus time graph was? I'm looking for a word that begins with letter A. Okay, if I wanted to generalize this, it's really the acceleration times t. And what I'm finding, actually, is the final velocity. What's that 2? As a concept. What's that 2? Yeah. In fact, Sally, what we've just done is derive the equation that we looked at yesterday, except yesterday, last class, I wrote it as VF equals VI plus AT instead of VF equals AT plus VI. But actually, that equation comes from a graph. It's just for some reason traditional in physics to put the VI in front of the AT. In math, we go MX plus B. In physics, we go B plus MX. I don't know. We just do. But that's going to be one of your 4 kinematics equations from today. You don't have to memorize it. It's on your formula sheet. Probably, Mina, in this unit, you will memorize it because you get sick of looking it up, which is the only reason you should memorize something, because you get sick of looking it up. Okay. So, by definition of constant acceleration, I wrote acceleration is the velocity change per second. Total velocity, you know what? Here's our equation, our first equation. V final equals V initial plus AT. That's the speed equation with scalars. If I want to make it work for vectors, vector sign, vector sign, vector sign. It works for vectors or scalars. Works for speed or velocity. What we want to do today is say, what if instead of how fast, I want to know how far? I want to bring in distance. And then I'm going to see what new equations we can generate. So, to find displacement or distance, we can't use this equation because this is only true if you're not speeding up or slowing down. However, I can use displacement equals average velocity times time. Oh, that's an A. Why did I put an A there? Try that again, Mr. Duick. Average velocity times time. If you're speeding up and slowing down, as long as I know your average velocity, I can multiply that by the time, and I'm going to be okay. I'm going to use one more thing. Josh, let's suppose you have $10 and Jaden has $20. What do you average between the two of you? How'd you get that? In fact, I think I picked on you the last time I did this question, didn't I? See how I remember these obscure? Okay. So the average velocity is calculated by, what did you say? Add them together? Now, what I mean by adding them together, add your initial and your final and divide by 2. So Jordan, what I'm going to do is stick this in for average velocity. This is going to give me a new equation. It's going to go in the box down here. Here is a displacement equation. Displacement is equal to VI plus VF over 2, and then the T just drops down like a domino from right there to there. Can you see where that equation is on your green sheet? I think it's right next to the VF equals VI plus AT, except on your green sheet, I think, Mackenzie, I wrote it a little bit differently, did I not? I think on your green sheet, instead of dividing by 2, that's the same as multiplying in the front by what? Find it on your green, okay. Ah, what? Right, by half. So I wrote it this way on your green sheet. 1/2 bracket VI plus VF times T. This is our second kinematics equation. It's really this one, average velocity times time, done properly. So now we can speed up and slow down. This only is legitimate if we're dealing with a constant acceleration, but that's all we're dealing with this year anyways, and next year. You all see where it is on your green sheet? You need to know this. So there's that VF equals VI plus AT. That's about 3 lines down on your green sheet and right next to it. In fact, in that row, there are 4 equations. Those are the 4 we're going to be flogging inside and out for the next few days. Yeah, we can turn the page. Oh yeah, here I said this assumes uniform, unchanging, constant acceleration. If you have a changing acceleration page, you need calculus. We're out of luck. So Josh, you just told us if we have uniform acceleration, we can find average speed or velocity by adding them up and dividing by 2. And it doesn't matter whether I go final plus initial or initial plus final, because when you're adding, order doesn't matter. 6 plus 4 and 4 plus 6 give you the same answer. VI plus VF and VF plus VI give you the same answer. Want to now derive probably the toughest but most useful distance equation, displacement equation. You do not need to know how to derive it. Krisha, I always show kids where it comes from. You don't need to know this. You need to know how to use it. That's what you'll need to know, how to use it, but not how to derive it. So I'm going to do a little algebraic argument. I said that distance is defined as average speed times time, which can be written as VF plus VI over 2 times time. Conlon did the same thing. I just replaced average speed with what it is. You okay with that? And, Mina, can you read this to me, please? The thing that I just underlined.
Oh, VF equals VI plus AT.
You're right. Say it again. You're right. Say it again.
VF equals VI plus AT.
What does VF equal?
VI plus AT.
Yep. So when I see a VF, what can I replace it with? VI plus AT. You okay with that? I'm going to do that. I'm going to take this VI plus AT, and I'm going to stick it in for that VF. Because that's what you just told me. You told me VF can be replaced with VI plus AT. I'm going to get this. D equals VI plus AT plus VI all over 2 times T. So Lexi, this VI plus AT came from this VF. The second VI, whoops, I didn't want to delete that. The second VI is just this one dropping down like a domino. And then there's the T, and there's the 2. Now, why did I do that? What's 1 VI plus 1 VI? What's VI plus VI? What's X plus X? 2X. What's VI plus VI? Not squared, that's timesing. X plus X is not X squared. X plus X is 2X, right? A plus A is 2A. VI plus VI is, fill in the blank, 2VI. Yes? They're like terms. So I can now rewrite this to get this. 2 VIs and an AT all times time over 2. Now I'm going to go like this. Dunk, dunk. Let's times that T in. 2 times V times T is going to be 2 VIT. Plus A times T times T. How can I write T times T a little shorter? Yeah, I'm going to get AT squared. And that's all over 2. Again, now I pause and let me emphasize. Mina, I'm not going to make you redo this. You don't need to know this derivation. Write it down because you're nerds. But Aaron, you're going to need to know how to use the equation that we're about to get. But I always show kids where this first one comes from. Aaron, my joy, is this being divided by 2? Say yes. Is this being divided by 2? Say yes. I can split them up then, and I can write it like this. 4, but each one of them contains 4, so a total of 16. But you don't need to memorize them. I'm going to teach you how to derive them in your head. Aaron, all I did was split up that big fraction and said each of them is over 2. Now, why did I do that? Because in this first fraction, I have a 2 on top and a 2 on the bottom. What happens to those 2 2's? And this is going to give us our final version of our distance equation. Distance, or displacement, is equal to VIT plus, instead of writing AT squared over 2, dividing by 2 is the same as timesing by a half. So I'm going to write it as a half AT squared. A half AT what? Squared. Those of you that are in Math 11, it's a parabola. It's one of the reasons we look at the parabola so much in math is it shows up all over the place in physics. So we're going to put that in this box here. D equals VIT plus 1/2 AT squared. And I think that's the third one over on your green formula sheet now. Yes? I think. See where it is. Find it, see it, find it. Mina said, how many equations are there? I said there's 4. There's one more. This one I'm not going to derive with you. If you want to know where it comes from, see me later and I'll show you. I'm just going to give it to you. Oh, well, you know what? It's the last one. The VF squared one. See it? VF squared equals VI squared plus 2AD. These, my angels, are the 4 kinematics equations. Now, sometimes instead of using final and initial, instead of using an I for initial, you may see them use a 0 for starting point, like on the graph at time 0. So I also wrote them this way just so you would see what they would look like if instead of an initial they used a 0. You'll see some books do one, some books do another. I use initial and final because that's what I say in English. The British tend to use zeros because they like V0. Let me just pause the video for a second. So these are the 4 kinematics equations. And all we're going to be doing today is learning how to do the math part of them. All we're going to be doing for the next few days is learning how to apply these. We're going to use my DFIC strategy like this. Today, I'm going to not give you the word problems yet. Today, I'm going to give you everything listed. We're going to practice just figuring out which equation and how to do the math. Next day is called applications of acceleration, and we'll start applying it to like RCMP crash investigations and all sorts of stuff. All right? So, you may recall my DFIC approach stood for list your data. I've done all that for you today. What we're going to practice today is finding the correct formula, inserting the numbers, and calculating the answer. You're going to want your calculator out. All right, number 1. Conlon, if you look at number 1, what are they asking me to find? I caught you zoning, I know. What are they asking me to find? It's the thing that has a question mark next to it. Okay, time. What have they given me? They've given me VF, VI, A, and they want me to find T. Your job right now is to look at those 4 equations on your green sheet and tell me which equation has a VF, a VI, and A, and a T in it. Don't say first one. Read me the equation. Jordan, which equation? Yes, you're correct. Let's write that down. VF equals VI plus AT. Conlon, what am I trying to find? I want to get the T by itself. I'm going to put a red dot above the T. You don't have to, but that's just so you can see what I'm focusing on. What side is the T on? Left side or right side? I'm going to leave it where it is. I'm going to move other stuff around. Okay? What's this A doing to the T? How will I move it over? What's the opposite of timesing? We're going to use your graded equation solving rules. What's this VI doing? How will I move it over? Which one do I do first? The answer is you go reverse BEDMAS. You do your adding, subtracting first, and then you do your multiplying and dividing, because you're actually trying to go backwards and find an answer. Okay? So the VF is just going to drop down like a domino, because we haven't done anything to the left side. I'm going to move the VI over. How? You're right. And that would leave me, don't write this next bit down. Don't write this next bit down. Instead, just see it in your Sesame Street imagination. Mina, in my imagination, I see the AT kathump drop down like a domino, except I'm trying to get the T by itself. How can I move that A over? Okay, so here's what I see in my head. I do that, and then I would normally write equals T, but do you mind, can I put T equals to, on that side? Because that way the T's by itself, and on the left where I'm used to seeing it. We call this, Tyler, formula manipulation. It's going to seem weird at first. Some of you are going to want to put in numbers. Do not. Resist the temptation to just stick in numbers and then start solving. If you get good at the algebra, if you get good at the formula manipulation, I've dropped your memorization by about 90% and I've dropped your workload by about 50%. It's going to seem weird at first, but trust me, I've done this before. We now have, Mina, yet another equation. Not going to memorize it. You're going to get good enough to derive it from this one that honestly in about 2 weeks, most of you will be doing all this in your head. And I'll let you. If you get that good, if you can do it all in your head and go straight to writing stuff, I'm good with that. Now, let's plug and chug. What's VF according to this question?
29.6.
Yep. This is why I always make that little list. Minus, what's VI? 3.2 divided by, what's A? 2.9. I also did a quick check. Everything is in meters and seconds. I don't need to do any conversions. I didn't see any kilometers kicking around or hours kicking around. Now, get your calculators up. Before you start typing, is this a fraction? Everybody say yes. Yes. Is there more than one thing on the top of the fraction? I have to put the top in brackets. Is there more than one thing in the bottom of the fraction? I don't have to put the bottom in brackets. Now, the only exception, some of the new Sharp calculators, apparently when you go to wide mode, you can actually have a 2-line fraction and use your cursor to put stuff on the top and put stuff on the bottom, in which case there, I don't think you need the brackets, but I don't know how many of you have that particular calculator. I only saw that one for the first time yesterday. For me, I go like this, bracket 29.6 minus 3.2 close bracket divided by 2.9. I get 9.10. Oh, how many sig figs should I go to in this question technically? I think 2, 3.2 and 2.9, 2 sig figs. I'm going to go 9.1. Units, time. Time. Seconds, yep. This is the approach we're going to take initially, this DFIC approach. Eventually, we'll get good enough that we'll cut corners and we'll do a more generic approach, but we're going to start out here. We'll start out here.
For the answer, can we also just say 28.4?
No, can't be 28.4. It's not 28.4.
Oh, I forgot.
That's why I said, is this a fraction? Yes. You have to put brackets around the top because there's more than one thing on the top. Okay? This is, by the way, make sure all of you are practicing these on your calculator because we're going to get pretty complicated pretty quickly. This is where you get to make your mistakes. Leah, my joy, what are they asking me to find in example 2?
Yeah.
No, I think VI is negative 1.5. Yeah, are we cluing in? You look for the question mark, right? Okay. They've given me VI and A and T and they want me to find D. Which equation? There's only one that has all 4 of those. Which equation? Leah, my joy, which equation?
D equals VI.
Yes, plus a half AT squared. That's how we'll say it. We'll say D equals, some people will like D equals the initial velocity times just VIT plus a half AT squared. Read the letters and we're good. We'll figure it out. Let's write that down. What am I trying to get by itself? Oh, it already is. Cool. Straight plug and chug. Now here's, by the way, if I gave you this as a word problem, here's what I would have said. Suppose you start out going backwards at 1.5 meters per second, and you're accelerating forwards at 4.5 meters per second squared for 12 seconds. How far do you go? To try and answer that by making like a chart like we did last day at the beginning of class would be crazy. But we can now get this pretty easily with our calculators by plugging and chugging. It's going to be negative 1.5 times 12 plus, how do I type 1/2 into my calculator? Yeah, Jordan? Loud and proud. Yep. 0.5 times 4.5 times 12. Oh, 12 what? 12 squared. The most common mistake kids are with this equation, they're so proud they've got everything in the right place and they let their guard down and they forget to put the squared on. Now, little comment before you go to your calculators. To show multiplying, in my handwriting, I use brackets. I would not do that on a calculator. I would use the times sign. In other words, I would get my calculator out and I would go negative 1.5 times 12 plus 0.5 times 4.5 times 12 and then hit your x squared button. Try that. And I end up with 306. Is that okay, Leah? Technically, how many sig figs should I go to in this question? 2. So I'll write down here, or 310 meters. I'd take both. I'd take both. kick it up a notch. Jaden, what are they asking me to find in example 3? Which one? VI. Yeah, because now there's always going to be 2 velocities, an initial and a final, because we're accelerating now. So VI. They also gave me an A, a T, and a D. Jaden, which equation? Stop, I don't know VF, can't use that one. And I'm glad you did that, but did they give me VF? Can't use any of them. In fact, don't use anything with a VF in it. And that's actually how I do these. I look at what they didn't give me, and I make sure I don't read any of those equations. There's only 5 things: VF, VI, T, A, and D. They're going to give you 3, find the 4th. Yes? This is the toughest equation. Okay. What are we trying to find? I'll put a little red dot above it just to... Okay. Jaden, what's this lowercase t right here doing to the VI? So how will I move it over? Divide later. I do my division and multiplying last. What's this half AT squared, which is all one big uber term? What's this half AT squared doing to the VI? How will I move it over? Subtract. What's already on the left-hand side? So it's going to just drop down like a domino. And you're telling me I would subtract, instead of 1/2, I'm going to write 0.5 AT squared. I would move that over by subtracting because it's plus. Don't write this next bit down. Just see it in your head. In my head, I imagine that this has now dropped down like a domino. Ka-thunk. What am I trying to get by itself? How? Ah. So if I can just see that in my head, I could now go divide by t, and I could even put the VI over here by itself and say that equals VI. Mina, is this a fraction? Say yes. Yeah. Is there more than one thing on the top of the fraction? I'll have to put the top in. Is there more than one thing on the bottom of the fraction? So I can be sloppy there. Alrighty. D. Jaden, what's D? I guess we ended up 40 meters behind from where we started. Minus 0.5. What's the acceleration? We're accelerating backwards. (24 squared) all over 24. Put your pencils down, look up. I mentioned a few minutes ago, I don't use brackets to show timesing on my calculator. I use them to show multiplying in my handwriting. Yes, yes. And the reason is, if I actually wrote on my calculator how I wrote it here, it would look like this. Just watch, don't do this. Negative 40 minus bracket 0.5, close bracket, bracket, negative 3.5, close bracket, bracket, 24 squared, close bracket, close bracket. I'm going to argue that's really confusing, because it's tough to tell what's on top and what's on the bottom. I mean, I'll get the right answer because I know how to type this, but I'm going to say, pick your calculators up, it's much easier to go negative 40 minus 0.5 times negative 3.5 times 24 squared, close off the top, divided by 24. I think that second one is easier to read. Agree with me? So you don't have to. I mean, you can use brackets all the time you want to show timesing. I just won't. I also get 40.3. See if you get 40.33333. Type these in. Everybody get that? Yeah. I should probably go to 2 sig figs, but I'm just going to go 40.3. Jaden, units? Yeah, because we found a velocity. No yawning. Is that okay? couple more, and then the rest of the class is going to be you practicing this, being able to rearrange an equation. Again, I've done this before. For some of you, it's going to seem really weird. Be patient. I'll walk you through it, and you'll get good at it. Example 4. Example 4. McKenna, what are they asking me to find in example 4? Yep. All right, folks, I'm looking for an equation that has VF, VI, A, and D in it. Which one? McKenna, my joy, can you figure it out? Yes, good. VF squared equals, keep reading. Yep. What did you say we're trying to find? I want to get the VF by itself. Do I have it by itself? Almost. I have a VF squared by itself. So here's the question. How do I get rid of a squared? What's the opposite of squaring? Square rooting. Okay, I want to show work, but I don't want to write a lot of crap. So here's what I will, if you're doing the square root thing, look up, look up, look up. I'm happy if you go cross out the squared and put a square root like that. That's enough work for me. I changed colors just to make it stand out. You don't have to, but just to let you know, oh, how to get rid of a squared? Cross out the squared, square root the other side. Square root both sides. Now, we can plug and chug. It's going to be big square root 12.5 squared plus 2 times 9.8 times 126. Tricks of the trade. Look up again when you're done writing for a second. McKenna, we're going to get, as the year progresses, into some very long, complicated expressions. So one of the things that I always do to show where my square root ends, do you notice I put a little downy pointy part right there? That's a habit I've picked up so that if I see a number right here, I know it's absolutely not inside the square root because that's where I've cut my square root off. You don't have to do that. It's just a good habit. How do we type this into our calculator? Here's what we're not going to do. We're not going to go square root of that. Instead, the best way, the easiest way, is to type what's inside there. So get your calculator out. Don't hit your square root button yet. Instead, go 12.5 squared plus 2 times 9.8 times 126 and hit equals. Should get 2625.85. We're going to square root this, but we're not going to retype it. Instead, I'm going to go square root answer button. And this is the time where all of you must now figure out where your answer button is. And if you don't know where your answer button is, now I will come help you find your answer button. And you end up with 51.2. So who needs help finding their answer? Everybody get the 51.2? I hope. 51.2 units, it's a velocity. McKenna, units, it's a velocity. What units would it be? It's a velocity. Psst, psst, stop, stop, stop. Look up. What units did I put next to this velocity? No. What units did I put next to this velocity? Ah, see, I can figure it out. You can always, if you can't remember what units go with what, I guarantee it showed up either in your question or somewhere in a different question. 2 more, we're done. The rest of the class will be yours. Nice yawn, Raven, I saw that. Connor, my friend, in example 5, what are they asking us to find? A. And they gave me VF, VI, and D. Which equation, folks? Which equation am I going to use here? Yes. This is the second toughest equation to work with. That's a squared. Ugh. What am I trying to find, Connor? I'll put a red dot above it just so you can see what I'm looking at. I'm staring at that. What's this 2 doing to the A? How will I move it over? Later. What's this D doing to the A? How will I move it over? Later. What's this VI squared doing to the A? How will I move it over? I do the adding, subtracting first. What's going to drop down like a domino over on the left-hand side without me even touching it? Okay, you see, you can almost see the steps. So the VF squared just drops down. What next, Connor? Stop clicking the pen. Thanks. What next? No. We're never going to touch the A. It's going to stay there. We're moving everything else. So you ready? What? It's good. VI squared. How am I going to move it over? How do you know? Yeah. Then, don't write this next bit down. In my imagination, I see the 2AD just having dropped down, but I want the A by itself. I need to deal with the 2 and the D. Conveniently, they're both doing the same thing. How will I move the 2 and the D over? Divide. Why? Yes. So are you telling me, Mina, that there would be a 2D on the bottom? And if it's okay, do you mind? I'm going to put the A equals on the left-hand side by itself because that's what you guys are used to seeing from your equation solving days. Mina, is this a fraction? Is there more than one thing on the top? So what will I remember around the top begins with letter B? Is there more than one thing on the bottom? Yeah, a 2 and a D. So what will I remember around the bottom? Yep. Let's carefully write in the numbers. It's going to be, oh, one more thing. What's my final speed, Connor? What's VF? Don't overcomplicate this. What's my final speed? What was my initial speed? Am I speeding up or slowing down? Look at the numbers. Am I speeding up or slowing down? I'm going to ask you the same question. I'm just going to phrase it differently. Am I going to get a positive acceleration or a negative acceleration? If I get a negative, I won't freak. I'll smile. Okay? There's some built-in error checks here. I know I have to get a negative acceleration. So it's going to be 12 squared minus 20 squared all over 2 times 86. In English, if I gave you this question written out, I would say, suppose you start out at 20 meters per second and you want to slow down to 12 meters per second in 86 meters. What do you need to decelerate at? That's what we're finding. Bracket 12 squared minus 20 squared. Close bracket. Try this on your calculator. If you're not, you're setting yourself up for failure. Divided by 2 times 86. You need to be able to get negative 1.48893. How about negative 1.5? I'll go to 2 sig figs. And it's an acceleration, Connor, so what would the units be? Yes. Last one. Last one. Sally, what are they asking me to find? Which equation? There is one. Nope, I don't know VF. Can't use it. So read me the one that doesn't have a VF in it. Yep. This equation, for you guys in grade 11, is very, very tough to solve for t. Because, Sally, it's a quadratic. It actually needs the quadratic formula. You're grade 12. So it actually needs x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Unless, there's one more thing. Sally, what's VI? We can only, at this stage, handle this equation to solve for time if VI is 0. Because, Sally, what's 0 times 5? What's 0 times 10? What's 0 times a million? What's 0 times t? Because VI is 0, this whole term just cancels. And I get, sorry Mina, yet another equation. This one. D equals AT squared. And instead of a times by 1/2, I'm going to write it as divide by 2, because dividing by 2 is the same as timesing by 1/2, but that looks prettier. That's a special subcase of the distance equation when VI is 0. Or in English, when you're starting at rest. Sally, what am I trying to get by itself? What's the A doing to the T? How will I move it over? What's that 2 on the bottom doing to the T? How will I move it over? So if I hear you correctly, the D is just going to drop down. There's going to be a 2 in front of it and an A beneath it. Now that doesn't get the T by itself. That gives me a T squared by itself. Oh, how to get rid of a squared? Square root. There you go. Yet another equation. Don't memorize it. Don't write it on your green sheet. I won't let you. We're going to learn to derive them. T equals the square root of 2 times the distance divided by 20. 2 times the distance divided by 20. And then square root of that. Some of you can do this all in one step, and that's fine too. I get 15.49, 15.5. Is that right? Anybody else? Sally, 15.5 what? Units, seconds. So all we're doing today is realizing we have 4 equations we can use. We can identify which equation by a process of elimination, and then we can practice getting stuff by itself. Your homework, and I'm throwing a lot at you because you need to practice this, is all of these. You can do the work right on the sheet if you write small-ish, or if you want to do a separate piece of paper, you can. The answers are at the very, very bottom, but they're scrambled. You'll find the answers somewhere in there. You can kind of cross them out as you go. So the answer to number 1 is not 115 meters per second, but somewhere along the way, one of your answers will be 115 meters per second. You got about 10 minutes left. Use this to get a head start, kiddo.